this afternoon in Nairobi, at least, I would like to welcome Njoki Kiarie. She's our speaker today. She works at, she's a software developer at UTrust, and she'll be giving a talk on event sourcing and CQRS in Elixir. Go ahead, take it away, Njoki.
Well, thank you, Mush. So I think I don't need my about me slide. You said everything. So Njoki Kiarie, software developer at UTrust. So something little about what we do at UTrust is we are in the Web3 space. We provide a payment gateway for cryptocurrency. So merchants are able to accept crypto in their platforms. Likes, I enjoy a good book, a good series, I enjoy cycling. Those are my socials. So at work, our main language is Elixir. Our main backend language is Elixir, and it sort of inspired my talk because we have been using event sourcing and CQRS. So I want to share some of the things that I've learned. So we can start with what is event sourcing. It's a pattern for storing data as events in an append log only. So unlike normal databases where we store the latest state of data, in event sourcing, we store everything that happened. So let's say a user was created, this user changed their email, this user updated something else, we are able to see the whole trail. We just don't store the latest state. So this is an example of event sourcing in a banking system where you create all these events and all these events are persisted in an event store. So we have an account created, money was deposited, money is withdrawn, KYC is approved, and all these events are stored sequentially, so as they happen. Then we have something else that is commonly mentioned every time you're using the event sourcing pattern, which is CQRS, CQRS is command query responsibility segregation. It's a pattern that helps us to segment our system into two. So we have the write model and the read model. So one part of the system is responsible for writes, the other part of the system is responsible for read. And we can further break this down into having the read DB and the write DB. So we have two parts. So the last part on databases is not exactly CQRS, but it's just a way of adding to CQRS. So CQRS just means you separate the methods for read and the methods for write. But then if you want it to be more efficient, you separate the write DB and the read DB. And then now when we match the two together, that is event sourcing and CQRS, what changes is our write model. So our write model becomes an event store. And then for us to create our read model, we have an event handler that is subscribed. So every time there is an event, the event handler updates our read model. So, and that is how they use together. So with these two patterns, for us to achieve this in Elixir, we have a library called commanded. So we don't need to do everything. We don't need to create the whole architecture because commanded provides the building blocks for this. So some of the things that come with commanded is command registration and dispatch, hosting and delegation of aggregates, event handling. It helps us to support long-running process managers. And as we go through the talk, we'll see how we are able to achieve this with commanded. So some of the keywords to help us understand event sourcing and CQRS. So domain, so this is basically a field for which a system is built for. So a bank, a hospital, e-commerce. A command is a request, which says, which conveys the intent of the user. And commands are usually named according to the domain, so, and according to the purpose for which that command has been created. So for example, create account, which is a command to when you want to create an account for a user, check balance when the user is checking balance, and they're always in present tense. Events, a representation of something important that happened in the domain. So an account was created, KYC was verified, money was withdrawn. And the thing about events is that they're immutable. So once an event happens, it can't be deleted and it can't be updated. So what's in case there's an error in how an event was created, for you to correct that error, you have to create a new event. Yeah. So then we go on, we have aggregates. So in commanded, aggregates handle commands and create events. So what aggregates do is that they enforce business rules. So maybe one of the rules in when we are withdrawing money is that you must have money. So it checks if this account has money, and then if you have money, then it creates the account for money withdrawn. Then we can't read from aggregates. It's a write model. Yeah. And then we have event handlers. So as we saw in our earlier diagram, event handlers allow us to execute code. They receive events and then they do something based on those events. So they help us. So in case an event handler is a projection, then we can create a read model. Maybe the event handler is one for sending emails, so we can send emails. So depending on what we need to do. So assuming a user was created, we can, and then we get the event user created, we can send an event to an event handler that updates the read DB. And now we have a new user. We can also send it to an email handler that sends a welcome email to the user. So yes, so that is the back of event handlers. And then we have process managers, which do the opposite of what aggregates do. So they receive commands, they receive events and dispatch commands. So aggregates can't communicate directly. So assuming we have a bank aggregate, so the one that's responsible for accounts, and we have a loan aggregate, they can't communicate directly. So they need a process manager. So think of a process manager as the middleman. And then, so here is an example of how commanded works. So we have the user interface. A user sends a command which is routed to the aggregate. The aggregate enforces the business rules and creates an event. If the command was successful, that event goes to the event stores, it goes to the process manager. In case maybe we need it's needed by another aggregate, it goes to the projector. The projector then updates our read model. And then if the user decides to query something, they query it from the read model. So let's do a code example. So we're going to create a banking system. And some of the requirements in a banking system are opening an account, depositing money, withdrawing money, transfer money, verify the user, so verify KYC information. So we start with commands. So this is the structure for commands in commanded. So it's just a def struct, yeah? And yes, so it's just a def struct. So we have create account, we have verify KYC, deposit money, withdraw money, and request money transfer. Then for this scenario, we have events. So we have account created, money deposited, KYC verified, money withdrawn, and money transfer requested. So as we saw that commands are present tense, events are past tense, and they're all named based on the domain or what's the purpose of the said events and commands are. So now that we have events, we have a command. So let's say something like create account. We use commanded comes with a router. So this router helps us to know which aggregate to dispatch which command to. So for this case, we have said dispatch these commands to bank account. And the identifier is an account number. So that's our ID. It's our unique ID. So we have, this is an example of an aggregate. So, and it's responding to commands create account, and all these other commands that have been dispatched here. So as we discussed, aggregates allow us to enforce business rules, and they also have states. So as we can see, we have a def struct, which initially the account number is nil, the status is inactive, and the balance is 0. So when we say create account, aggregates have 2 callback functions. So we have execute and we have apply. So execute allows us to enforce rules and to create the event, and apply allows us to update the state of the aggregate. So as we can see, we on the function execute, we send out a state, we accept a state and the command, and then we respond with an event. So for this case, we are saying that we are pattern matching. If the account is nil, then we can create an account. Yeah, we can send account created if the account number is nil. But if the account number is not nil, then we give an error that the account has already been opened. Then we have another command, which is verify KYC. So we check if the account number exists, and if an account number exists, then we have sent this verify KYC. Then we can send this event that the KYC was verified. And then our apply function just updates the state. So for every execute function, if there are changes that need to be done to the state, then there's an apply function. So this apply function is for our create account execute function. So we have, so for the apply function, the parameters are the state and the event. So, and then we return an updated state. So bank account, so this is our bank, this is our state, and then we update it with the account number. Now that this particular user has an account that has been created for them. Then we have the process manager. So we have a process manager. So a process manager communicates with different, allows communication between different aggregates. And then it also has callback functions. We have interested, we have handle, and we have apply. So interested checks if the process has been started. So for every unique identifier, there is a process that has been started for that, that should be started for that identifier. And then we have handle, which takes in the state of the process manager and the event and returns a command. And if no command is necessary, so maybe if the only thing that needed to happen was updating the state of the process manager, then we return an empty list. So for this case, let's say we have, then we have, so interested has 2 responses. So start plus the identifier, or continue and the identifier. So what this means is the KYC verified is the one that starts our process for this account. So before the KYC verified event is sent out, that means we have not started this process. So in case we try something else, like withdrawing money or trying to transfer money, and the KYC has not been verified, we get an error. So it says that this particular process has not been started. So this is where our process manager starts. And we could start it at account created, but then users can create an account and then never do anything with it. And then we just have a process that's running, and it's not being used. So we're just using resources. So we have decided that we are going to start this process when a user is verified, because now we know they're sort of serious and they want to create they need this account. So then we have another example. So for KYC verified, what it does is it's handled, and since there is nothing happening, like we don't need to send a command to anything else. We just want to update the state, our state, which is here, from inactive to active. What we do is just the handle event returns an empty list, and our apply function updates the status to the status and the account number. So an account number and the status at active. And now this particular account can start performing all the other functions. Then let's take another example for transferring money here. You want to transfer money from account A to B. So you send out a command to request money transfer. Our aggregate checks the command, and if it's accurate, it creates an event called money transfer requested. The process manager, which does the opposite of the aggregate, takes in that event and checks if there's a process already started for that account number, since we said that our account number is the identifier. And then so it checks, and if this passes, then that is handled. So we have the def handle, which checks in the state and the event. And then, so if we get a money transfer requested, that means we would need to withdraw money from one account, so account A, and we need to send money to account B. So we send out a request to withdraw money here, and the account number is the sender. So because for our, if we can remember, our event transfer money had a recipient, sender, and amount. So our account number for withdrawing, that is going to receive this command for withdrawing money, is the sender, and the amount that's supposed to be withdrawn. And if this is successful, if withdraw money is successful, then we get, if this command is successful in the aggregate, then we get money withdrawn, another event called money withdrawn. So, and then the process manager now handles this, and now we can deposit money. Since money was withdrawn, money has to go somewhere. So for deposit money, our account number where we are depositing this money is the recipient. Yes, so this is how a process manager works. Oh, and then something else, process managers have unique names. They all have names. They have unique names because they are all subscribed and they need to listen into events. And this variable start from basically is you saying where you want to start your process manager to listen from. So you can start from origin, from when the events work, the origin of this event's been created, or you can start at a different time. Maybe you want to start from the newest event, so current. Then yeah, and then so this is how Elixir or Commanded helps us work with implement the ES CQRS pattern. What happens is that, like, the only thing you need to focus on is the business logic, because most of these things come with Commanded. Then something else is you can, there's something called eventual consistency. So one of the problems with event sourcing and CQRS is that the read model can be updated later. So we have events streaming in, and then after these events are persisted, they're published, and then the read model picks up on this. So we can have a point where what the read model is saying is not exactly what is in the event, but at the end of it, we are going to have both of them saying the same thing, like the most recent state at some point is going to be the same thing. So how Commanded handles this in case you need your data to be consistent is you get to specify when you're dispatching commands. So we have consistency. You either say if you want consistency to be strong or if you want it to be eventual. So for maybe things like a retail store, maybe or a blog, you don't need it to be 100% accurate. Like what the reader is reading is what is the most current event. But in a banking system, you want a case where what you're reading, what you see as your bank balance is exactly that. So you get to state that you want the consistency as strong. So many things come with Commanded, which makes it very easy for us to use it. So for me, some of the benefits I've seen where the CQRS pattern is concerned, one of them is data integrity. The fact that events are immutable, that once it has been created, you can't update or delete it. It's there for life. You can be able to go back and see what happened. I find that comforting. Then something else is event sourcing can help prevent concurrent updates from causing conflicts because it avoids the requirement to directly update objects in the data store. So with event sourcing, and so with normal DBs, if multiple people are updating the same row, then there might be conflicts. But with this, since we are not writing directly to our read model, every event will be saved and every event, and then eventually our read DB will be updated with the right information. So then something else is that we are able to replay events to recreate the read model in case our data is corrupted or lost. So in case someone changed something on the read model and the data doesn't add up, we are able to recreate this at any point. Then the fact that we have events and we are storing them sequentially in case we need to debug, we have a whole audit log of everything that's happened and we can see and spot where things went wrong. Some other benefits I've seen is scalability. So now that we have separated our read and write model, then it's very easy for us to scale our system. So for example, in an online retail store, we have more reads than writes. So we are able to scale one and we are able to scale the parts that is read and not necessarily scale up the write model because it's not as intensive. Something else is research and development, some other benefits. And this is because we have all this information. Like imagine for every user in that banking system of ours has 1,000 rows. So much information that can help us detect user behavior trends, or just useful information that can help a business make better decisions. Nowadays we say data is king. So that is one of the benefits for me. Number 4 is integration with other subsystems. So think of, we have one event store and then we have all these other other subsystems. So think of a banking system, and then we have a loan app, we have a mobile money app, we have the actual user account app, we have maybe back office, and all these other subsystems can just read from the event store. So cons, a bit of a learning curve. It has taken me a while to figure out what exactly event sourcing is, and the fact that it doesn't come out of the box. So for normal databases, when you need to create, especially in Elixir, Phoenix, you just use Ector and you just do migrations and you're good to go. But with But with event sourcing, you sort of have to do a few things for yourself. You sort of have to write out the architecture, but then we have commanded, which makes it a little bit more easy. So there's that. So it's a con, but learning is not a bad thing. There's high memory usage because for something that could have been one row in an RDBMS is a million rows on event store, but this can be solved using snapshots. So snapshots is you taking a picture of when at a certain point in time. So you take a picture and then save that, and then when we need to replay or recreate the events, we recreate events after that snapshot. So that means we can delete everything. We can delete all these events because we have the current state of that snapshot. And then when we need to replay the events, we start from that snapshot. So that helps with getting rid of all this information if memory usage is actually an issue. And then there is the issue I talked about, which is eventual consistency. So the eventual consistency is good because it allows for high availability, but for systems that are you need for the data to be accurate, then you can use, when you're dispatching commands, you can specify that you want the consistency to be strong. So you have high latency, but you still get your data right. So when should you consider event sourcing CQRS as opposed to our normal way of going about writing applications? So I have three. So one, when your system aims at being large with many business scopes. So think of a retail store where you have shipping, you have the actual e-commerce store, you have products, you have all these things. So if you know that your system is going to grow and there are going to be all these subdomains in that domain, then event sourcing and CQRS will be a good way to go. The second one is if you're expected to keep track of any changes, if you need to know everything that happened. So for example, in our banking system where you need to know everything that happened, not just what the user's current balance is, then this is a good way to go. If you have a large team of engineers, this works. So you have separation of concern. That means different people can different teams can develop different aspects of the system separately. And yeah, this just works. And that's it. Thank you. Questions?
Okay, so there is one question. So what are the downfalls of using CQRS, and would you say it can integrate the application architecture and code base?
So what is the?
Okay, I think there are two parts to this question. So what are the downfalls to using CQRS?
Awesome. Thank you for that, Njoki. I've learned something new today. So I had a bit of an idea about CQRS, but I've never really had a good look. So thank you for that. There's one question by Tato. What are the downfalls of using CQRS, and what would you say? And would you say it can intricate the application architecture and code base? I'm going to rephrase that and say, and would you say it can complicate the application and architecture and code base? Yeah, so over to you, Njoki.
So what are the downfalls for CQRS? CQRS or event CQRS? So downfalls is you get to do a little bit more. Yeah.
I'm going to rephrase that and say, and would you say it can complicate the application and architecture and code base? Yeah, so over to you, Njoki.
So what are the downfalls for CQRS? CQRS or event CQRS? So downfalls is you get to do a little bit more. Yeah.
I'm going to rephrase that and say, and would you say it can complicate the application and architecture?
Thank you. So downfalls is you get to do a little bit more of work, but there's someone who I listened to who said the pattern is not complex, it's a solution to a complex problem. So maybe not the idea would be to not use it for systems that don't need it, then it would be an over architecture. But for a system where you need all this data, where you have multiple teams, where your business scope is large, then by all means use the patterns, because they're able to help you separate the concerns and allow you to work on different parts of the system independently. So complicating the code base, done right, it's actually pretty intuitive. Like when you do the separation of concern, and yes, it's pretty intuitive. So yes. I hope I've answered your question.
Hello.
Hello.
Awesome. I can't see any more questions. So Joseph Mutiga says, informative talk. He loves it. And you also have a few claps from John Marango as well.
Thank you.
Also, sorry for forgetting to mute on one side. I think you guys had an echo for a bit there.
It's okay.
Yeah. Otherwise, that was a really nice talk. I think we can hand over back to Sigu for preparation for the next talk.
Okay, thank you guys.